Okay, welcome to section 6b-1. We're going to be dealing with exponent rules today. Now, this is a algebra 1 skill, dealing with these exponents. But since a lot of people, for a lot of people, it's been a while since we've been in algebra 1, 2, and maybe some of them didn't cover it that well or didn't understand it that well the first time. I want to make sure that we're all solid on that before we move forward. First on the warm-up, expand and simplify. As usual, my recommendation is that when we get to a new screen, you pause the video, try the problems yourself, and then move forward. The classwork for today was really just an investigation, so students were working mostly on this on their own and figuring out the rules based on the patterns. So, expand, what I mean by that is if I have x to the third power, what that means is x times x times x. These parentheses indicate that I'm multiplying that by x to the sixth, which is x times x times x times x times x times x. Since I'm doing nothing but multiplying all the way across here, I am multiplying this a total of 9 times. So this is x to the 9th. Now, when I have x to the third to the 6th power, that's going to indicate that I am taking x to the third and multiplying it by itself 6 times. So x to the third, x to the third, x to the third, x to the third, and x to the third. So, if I were to make each of these x times x times x, which I'm not going to, and I would have a total of 3, 6, 9, 12, 15, 18 total, times that I'm multiplying x by itself, so x to the 18th. The other thing I want to do, just for the warm-up, is remind people how to deal with fractions, especially multiplying a whole number by a fraction or a fraction by a fraction. If I'm multiplying a whole number by a fraction, I multiply that whole number by the numerator. The reason for that is when I multiply fractions, I multiply straight across the top and straight across the bottom. So, So this is essentially 6 over 1. A whole number is anything divided by 1, so we can just leave it like that. So 6 times 3 is 18, 1 times 2 is 2, and then 18 divided by 2 is 9. So some of the vocabulary. X, whenever we're having a number or variable to a power, that is your base. The small number up above, that's your exponent. That tells you how many times to multiply the base by itself. If you don't already know this, I would put it in your notes for sure. And finally, the number in front, this is a coefficient. And the important thing to know about the coefficient is that it is not affected by that exponent, nor is it subject to the exponent rules that you're going to learn today. So, one of the things we talked about before everybody got started on their investigation was the difference between 2x to the third and quantity 2x to the third. So in 2x to the third, the x is the only thing being put to that third power. This is 2 times x times x. Whereas 2x to the third, this entire thing, because it's in parentheses, is being put to the third. So this is 2x times 2x times 2x. So the difference here, if we were to simplify this, it was already simplified to start, whereas this one, we'd multiply the 2 times 2 times 2, which gives us 8. X times x times x gives us 8 to the third. Cube rooting, or fourth rooting, or fifth rooting, or anything like that is if I have the cube root of 8, for example. that is the same thing as 8 to the 1/3 power. Like if I would put that in the calculator, I'd put 8 to the power of parentheses 1 divided by 3. That was a reminder going into the investigation. Hopefully that'll help if you go through the investigation on your own. All right, that's not applicable to the video. So, on this, I'm not going to go through every single one, particularly because when we start expanding out to the 36th and the 11th, it just gets ridiculous. But again, I would suggest that you pause and do this yourself. So, if I expand out x to the 3rd, x to the 6th, which I did in the warm-up, so let's look at x to the 5th times x to the 8th. That's going to be x to the, so 1, 2, 3, 4, 5. That's x to the 5th. 1, 2, 3, 4, 5, 6, 7, nope, 8. So the total number of times I'm multiplying x by itself, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And, not coincidentally, so this will be x to the 13th. That is the same as taking my exponents and adding them. 5 plus 8 is 13, 3 plus 6 is 9, so that ends up being, like x to the 9th, x to the 13th. So if I'm looking at x to the 13th and x to the 9th, which I certainly don't want to expand out, I'm going to take that and make that x to the 13 plus 9, which is going to equal x to the 22nd. So as I'm adding these things, x to the 10th, x to the negative 7th, that's still going to be x to the 10 plus negative 7, which is x to the 3rd. So the rule then, x to the a times x to the b is x to the a plus b. Powers of powers. When I have, and I'm just going to go through the rules on these. Some of them I'll talk more about why they work. If I have x to the 3rd times x to the 3rd, that expands out to x times x times x times x times x times x. So what that ends up being is x to the 6th. So when I have a power to another power, what I'm really doing there is multiplying them. So something like x to the 10th times x to the 20th would get multiplied out so many times. So this would be x to the 210. So my rule, when I have a power to another power, is x to the a times b. Fractional exponents, as we talked about in the warm-up and what we just did, we multiply these two exponents. So x to the 2nd to the 1/2 is the same as x to the 1st, or just x. X to the 3rd to the 1/3, again, is x to the 1st, which is just x. So essentially what I'm doing here is I'm using an inverse operation when I'm taking a power to the power of its reciprocal. And so this also x, this one, however, is going to be x to the 2nd, because 4 times 1/2 is 2. And the last one, I'm going to have x to the 18/3. That's really not written well, which is x to the 6th. So really, if I think about this, if I have x to the 2nd equals, say, 64, I'm going to take the square root of both sides. That's the inverse operation. And on the same note, if I put both sides to the 1/2, that's going to be the same thing, because those are inverse operations. This is going to end up being 1, so I have x alone. So taking the root is the same as taking its fractional exponent. So fractional exponents are just roots. So if I'm rewriting the radical form of x to the 1/2, that's the square root of x. X to the 1/3 is the cube root, is the cube root of x. X to the 1/4 is the 4th root of x. And if I have x to the 2/3, then this stays in that cube root, but it's going to be x to the 2nd, the cube root of x to the 2nd. So these first three are all x to the 1st, which is shown here, here, and here. And then this part goes there. So that's actually the 2nd root, which is the square root. So that goes there, that goes there. So x to the a over b is the b root of x to the a. All right. Now this one I'm going to go through a little bit more thoroughly because it helps understand the negative and zero exponents in the next part. So x to the 7th over x to the 4th. A lot of people remember the rule on this, but they didn't really understand why. I can divide out x divided by x. And the reason that I can do that is because x divided by x is equal to 1. If I divide that one out, or that pair out to 1, 1, and 1, that's not an arrow, it's a 1, then I'm left with x times x times x, which is x to the 3rd, technically over 1, but I don't really need the over 1, so I'm just going to write it as x to the 3rd. If I have x to the 9th over x to the 5th, same idea. All those 5 down at the bottom are going to divide out to 1, and I'm going to be left with x to the 4th. So I'm not going to go through this big process, but the general rule here, x to the a over b, x to the a over x to the b is x to the a minus b. And understanding that is pretty critical to understanding the zero and negative exponents. So I'm going to pause this and fill in all the expanded and non-expanded answers, and then we'll talk about it. Okay, so with all that filled in, on the left side, I expanded everything out and I kept it in its form that it, without any reductions or anything. Well, that's not true. I expanded it out and I canceled out what I could. So here I had 2. Because there's no exponent, it would be 2 to the 1st. So 2 to the 1st over 2 to the 5th, I had 2 over 2 times 2 times 2 times 2 times 2, which ended up leaving me, after I divided out one pair of the 2's, 1 over 2 to the 4th. And then on the left side, I used my quotient rule and subtracted 1 minus 5 to get 2 to the negative 4th. Here I did 3 minus 6 to do x to the negative 3rd. So when we have a positive exponent on the right, which is here, let's do a plus, here, here, and what we had over here was normal, nothing changed. When we had a negative exponent right here, here, and here, what happened over here was that if I have 2 to the negative 4th, I ended up with 2 to the 4th, but on the bottom of a fraction. Same thing happened here. 2 to the negative 3rd, I had 1 over, x to the negative 3rd, I had 1 over x to the 3rd. Down at the bottom, x to the negative 2, shouldn't have been x. That would make more sense. This was 5 to the negative 2, my apologies. Ended up with 1 over 5 to the 2nd on the other side. So when I have a negative exponent, my rule then is 1 over, not in highlighting, sorry, 1 over x to the a. So x to the negative a becomes 1 over x to the a. And that's important to note because anytime you are simplifying, the expectation is that you simplify with no negative exponents. All right, so then if I look at all my 0 exponents, 2 to the 0, x to the 0, those all come out to 1 because everything divides out. And every time something divides out, it divides out to 1. So x to the 0, anything to the 0 power, always 1. So those are the exponent rules. I suggest all the little places where we had what is the rule, I would write that whole thing down. It's important to know those, be comfortable with them, and be able to work with them. So that's it for 6b-1. Have a lovely day.